Remember how inverse functions work? They switch what you put in and what you get out, right? So a normal cosine, we put in an angle, we get out an answer. That's a normal cosine, right? That's normally what happens. So for inverse cosine, you reverse that, you put in an answer, and what you're looking to get out is an angle, huh? So this question is asking you for the angle whose cosine is negative root 2 over 2. Excuse me. So that's what it's asking. That makes sense? That's what inverse trig, that's what any inverse function does, is they switch inputs and outputs. Like an inverse toaster, you would put in the toast, get out the bread, right? It's reverse. Inputs and outputs reverse. So inverse cosine or any inverse function in all of math means a switching of inputs and outputs. So that must, the negative root 2 over 2 must be the answer. And they're asking us, hey, what angle will produce that answer for cosine? So remember what you do is you go to the unit circle and you try to figure out where, like, remember we have our 3 memorized spots in every quadrant. Figure out which one of those 6 spots has a cosine whose answer is negative root 2 over 2. So I'll give you a second to think about that. All right. So, did you guys finish that homework up okay? Are you keeping up? Math's a lot of homework. Trig's a lot of homework. I was looking over the homework for class. These are a long time. So we have the help. Get the help you need. Come see me, office hours. I'm 12 to 1, Monday, Tuesday, Wednesday, or back there, tutoring center. There's the help you need. Get the help to master these. All right. So we have a test in a couple weeks, right? Or next week. Okay. Yeah. So next Monday is our practice exam day. We'll do the same kind of thing where we take the practice exam for an hour, I go over it for an hour, and then Wednesday is the actual exam. So exam number 2, we have 5 exams, so number 2 is next week, Monday and Wednesday. So we're coming up on that'll be on chapter 2. So we're in 2.3 now. We just have section 2.4. We'll hopefully start 2.4 today and finish it on Wednesday. So we'll be done with all that material by Wednesday. Okay, so inverse trig function. So this exam will be all those graphs. Oh, that's right, you did all those tangent, cotan, secant, and cosecant graphs, right? That was the homework. All right, so this section is inverse trig function. So again, inverse functions switch inputs and outputs like a toaster switching bread and toast. So that means when it says that little negative 1 power means inverse, doesn't it? By the way, let me mention, it's bad notation on math's part. I don't know if you know, but I hope I don't confuse you more here. But negative 1 powers actually mean to flip something. I don't know if you remember that from your early algebra days. Like if you had like x to the negative 1. Do you know that really means 1 over x, doesn't it? I don't know if you remember that. So then you would think, and you should think, but math does a weird thing here, that cosine inverse really means 1 over cosine, which is really what? Secant, right? So you would look at that, a reasonable person would look at that and go, well, that's 1 over cosine, because that's what negative 1 powers mean, and any other time, and then therefore that's 1 over cosine. That's just secant. Why aren't we just doing secant, Mr. Heron? That would be a great question, and it's because math gets weird here, is really the answer. Negative 1, so the answer to that, and maybe I shouldn't bring up questions you don't have and just make things more confusing. But in case you have that question, it'd be a good question. Negative 1 powers do mean flip, reciprocal, not inverse. You see those are 2 different things? Yeah, maybe I need to make that clear. Flipping something else upside down, and which is called reciprocal, right? Like cosine with secant, you know. And inverse function, which is switching inputs and outputs, those are 2 different animals. Those are 2 different things, right? If I said, I don't know how to do it with the toaster. I don't know what an upside-down toaster would be. But you get the idea. So inverse function is really weird. You're switching bread and toast. Totally weird. Whereas an upside down, that's not that big a deal. You just turn it upside down. Well, anyway, long story short, negative 1 powers mean flip the thing upside down in the math world unless it's on a function. Isn't that bad? It's kind of bad at math. They should have done something else. All of a sudden, negative 1 powers don't mean negative 1 powers anymore, and they mean inverse. So, I don't know, maybe it's not good to bring up a problem you never even had. But I think they should have just put an I up there. There's Mr. Heron's little way of doing it, but I'm not in charge of the notation of math. I think they just should have put a little I up in the upper right-hand corner, and that would mean inverse function, you know. Because any other time we see negative 1 power, it means flip it upside down. But when it's on a function, you know what I mean by a function, like cosine or sine or tangent or f. If I go f negative 1 of x, that does not mean 1 over f. That means the inverse function, which means switch inputs and outputs. So anyway, math is just kind of inconsistent. I mean, they're definitely inconsistent. There, negative 1 powers suddenly change what they mean when they're on a function. It means inverse, it means switch inputs and outputs, not flip the thing upside down. It takes on a new meaning. All right. Well, anyway, there we go. So, so that means I'm looking for some angle here, aren't I? I'm saying what angle will have an answer that. Now, remember the small, medium, large thing? What is it? What root 1, root 1, root 2, root 3 over 2, right? This one's just a half. So small, medium, large, okay? So we see the root 2 over 2 thing, and we go, okay, that's medium. That's either got to be this one or this one, doesn't it? Because it's right in the middle. You with me on that? Makes sense? Because the mediums are in the middle, right? Whereas this dot and this dot, same thing in the other two quadrants, in the other quadrant, those are for the small and the large, right? Have you seen the way the things always work? The small and the large always go together, and the medium with the medium. So anyway, it's not these guys, because I'm looking at root 2 over 2, which is the medium. So it's either over and up or back and up, medium. Now, because it's negative, remember that all students take calculus. Where is cosine negative? Just in the first and second quadrant. Which of those two? Is it the first quadrant? No, all are positive. This means all the trig functions are positive in the first quadrant, huh? So it's in the second quadrant where cosine is negative, because only sine and his reciprocal, cosecant, are positive in the second. So yeah, cosine is negative in the second. It must be this dot right here. You with me on that? See how I narrowed that down? It's got to be that dot right there, because that's where cosine is negative, and that's a medium spot, and we're talking about a medium answer value. So it must be this spot here. Right? What is that spot? What is right in the middle? Well, this is 90. This is 180. So what's right in the middle of 90? Well, you just add 45. Huh? You just take 90 and add halfway, add 45. So this will be 135 degrees. That is the angle, except I believe they want it in radians, don't they? Yeah, they say radians over here in the blue. Radians. So I got to convert 135 to radians. But that is the answer. Now well, let me stop there and come back to what you might be thinking in a minute. Let's convert that answer to radians. So multiply by what? 180 degrees on the bottom. Pi, the pi 180 conversion thing. So what is that then? 135 over 180 pi. And then just reduce. Divide by 5, with your calculator. Or some of your calculators do it automatically, huh? What is that? What's 135 divided by 5? 20 and 27? 27, thank you. 27 over 36. Oh, we got to reduce again, huh? Then divide by 9, top and bottom. So 3/4 pi in the end. 3/4 pi. Is that okay? Is that good?
Is it not like 3 pi over 4?
Yeah, good question. Same, very much the same thing. I'll just say or. Yeah, really good question, because on the multiple choice test you want to know, because they might have it this way, you have it that way, vice versa. You want to know those are the same. Really good question. Do you guys know the principle? Because really the only difference between having this here the pie's in the front, here it's in the top. Did you know to be alone is the same as being in the top? Why? Because pi alone is pi over 1, really, huh? Anything alone is really over a 1. So for that pi to be alone means it's really over 1, means it's the same as being in the top. So good question. The answer will always be, yeah, alone is the same as in the top, because you're really over 1 when you're alone. Good. So the answer is either one of those. They're both the same. Questions on that one? Other questions I can answer? Yeah.
Why is it only in quadrant 1 and 2?
Excellent question. Yep, that's the other one I held off on for a second. I'm glad you're thinking. Yeah, because you might think, well, why isn't it quadrant 3 also, Mr. Chairman? Because, we have the 3 dots here and the 3 dots there. Why couldn't it be this dot or this dot? Now, not this one, because cosine is positive there, huh? So cosine's positive there, and all are positive. It's not first and fourth. But why wouldn't it be this dot here? Here the cosine's going to be negative root 2 over 2 also. It is, you're right. It's negative root 2 over 2 there also. Why is it not that angle? Well, basically, they only want one answer to inverse trig functions. I mean, that's simply it. They want only one answer to inverse trig functions. So they simply restricted where they're going to let the answers come from. That's the short. And so let me give you the story. Well, over here. So so to get only one answer for inverse sine, inverse cosine, inverse tangent, etc. They want only one answer. Why they want only one answer is a little bit of a longer story, which probably not a good time to go into it. Yeah, let me not. So anyway, they wanted only one answer. They want only one answer because they want the functions to be 1-to-1 and some other stuff, which you can talk about in pre-calc. But to get only one answer out of the inverse trig functions, because you're right on the money, otherwise there'd be two answers. There'd be an answer here and an answer here. They're both places where the cosine is negative root 2 over 2. They are. That's good observation. To make that not happen, so there's only one answer from these questions, what they do is they restrict cosine inverse to be 0 to 180, and and let me draw a little picture to help you remember that. On the unit circle, that means from here to here for cosine inverse, and then they restrict sine inverse and tangent inverse to be negative 90. Remember that one I did last time and ended up being, I messed it up at first. I wasn't following the restrictions. They restrict sine inverse and tan inverse to be negative 90 to positive 90. The right two quadrants, the first and fourth. That's what they do. So you do have to remember that. Remember, there'll be a couple of these questions. Well, you put on your 3x5 card, I mean. Somehow you have to have it with you when we take our exam next week. So these questions will be on part 1 where you have no calculator. So you want to make sure you can actually do these by hand. So I would definitely have this on your 3x5 card. Super important is to have those two facts right there about the restrictions for cosine inverse and sine inverse and tangent inverse. All the answers that means to sine inverse, tan inverse are between negative 90 and positive 90. And for cosine inverse between 0 and 180. Now what that means, let me point out. Remember the one we did right last time? It's been almost a week. It's been 5 days. But remember it came out somewhere down here in the fourth quadrant. And instead of saying like, I don't know what it was, 300 degrees or 330 or whatever it was, I said, oh, no, we got to change it to the same angle, but saying it in terms of a negative angle. That's why that happened. Does that make sense? Question?
So are their inverse functions the same or opposite of that? Like the cosecant, secant, cosine?
Oh, yeah, we're not going to go to those. Those are real confusing. Yeah, we'll stay away from those. We're just going to do these three. Yeah, the things get a little tricky with those. Yeah. I think, well, we'll see. If we get to them in homework, then I'll go. I can't remember, to tell you the truth. So maybe we will go there. Let me take that back. We'll see. If we go there when we get to homework, in this section, we'll know today. Then I'll talk about it. Otherwise, I don't want to confuse you with more information. Good on that? Is that making sense? So that's why. So maybe it really shows the point. Okay. Oh, actually, one more thing back here real quick before we move ahead. One more thing. So basically, notice cosine inverse and sine inverse, tangent inverse, they both have the first quadrant and one other quadrant where they'll be negative. Does everybody see that? Remember, all are positive in the first quadrant, right? Notice how these guys have the first quadrant and the fourth. Cosine inverse has the first quadrant and the second. See? Cosine will be negative here. Sine inverse and tangent inverse will be negative there. All are positive in the first quadrant. Does that make sense? So basically, when you look at sine inverse, tangent inverse, cosine inverse, any of these, and you see a negative answer, then you know it's not the first quadrant. It's their other quadrant, which for sine inverse, tangent inverse is the fourth. For cosine inverse is the second. Does that make sense? See how you discern right away? So if I give you a question, cosine inverse of some negative thing, you go, oh, second quadrant. You know you're looking for the second quadrant because that's his negative quadrant. If I go cosine inverse is some positive thing, then for sure first quadrant, all are positive in the first quadrant, you know, the all students take calculus thing, right? If I'm doing sine inverse or tangent inverse and I give you some negative thing, you right away go, oh, fourth quadrant, because sine is negative and so is tangent in the fourth quadrant. So positive first quadrant, they're all positive in the first. Make sense? So you look for that right away. Let's redo again real quick this number 2. We have the answer sitting there before us. So sine inverse of negative. So as soon as you see that negative sine inverse, you go, oh, fourth quadrant, somewhere down here, because that's the restriction for sine inverse and tan inverse, right? Fourth and first. First is the positive. So you go, okay, it's negative down here. So it's one of these 3 dots. Right away, we got it narrowed down to one of those 3 dots. And negative a half, remember the small, medium, large? A half, root 2 over 2, root 3 over 2, small, medium, large. It's not the medium, so I'll just say no to that one. Right? A half is small or large. Well, I mean, I know half's a small number, but, you know, where's it at exactly? So let's find it. So we go, is it over and down? This would be over a large amount, down a small, and this would be over a little down, or this would be over a half, down root 3 over 2. So which one is it? Well, sine is the y value. Like the coordinates of this point is over root 3 over 2, down a half. The coordinates of this point is over a half, down root 3 over 2. This is the cosine sine. Remember, cosine is x, sine is y. So which one has a sine of minus a half, a y value? This one. This dot right here. Right? Now what now? You could say, well, that's almost 360. That's 330 degrees, really. Yeah, that's true. But remember, we have to say it between negative 90 and positive 90. That's how they're making us say the answers to inverse sine and inverse tangent. Between negative 90 and positive. So say that angle, what is it? It's negative 30 degrees, right? This is negative 30, negative 45, negative 60. Make sense? So the answer is negative 30, but we got to convert that. So you put 180, put pi, so it's 30 over 180, negative 30 over 180. Come on. Negative 30 over 180 pi. 30 goes into 180 6 times, negative pi over 6. There's the clean way. I should have done that problem last time. Does that make sense? We good with that? With the inverse trig? Okay, it's all about that unit circle, isn't it? I hope you guys are getting more and more and more comfortable with the 3 dots in every quadrant of the unit circle and the small, medium, large thing. If you really get comfortable with that, these will... Okay, so they want us to do tan inverse of root 3 over 3. So again, this is the answer. They're asking for the angle, right? It's reversing of inputs and outputs. They want an angle. So right away, I would draw a little unit circle. Tangent inverse, it's one of those 2 quadrants, right? Tangent inverse and sine inverse are the right 2 quadrants. Cosine inverse are the top 2 quadrants, okay? So it's one of those 2. Which one is it? Is it the first quadrant or the fourth quadrant? Remember, everything's positive here, and tangent inverse is negative there. So what do we got? Positive. That's positive root 3 over 3. So we're talking first quadrant, aren't we? This is for sure. You know, any trig function is positive, first quadrant. For inverse, I mean. First quadrant. So it's one of these 3 dots. Isn't it? Well, how do you know which one? You better get the coordinates. So go ahead and get the coordinates of those 3 dots. You know what I mean? The x, y, like this point here. It's over what, up what. This point here, over what, up what. This point here, over what, up what. So this is over a lot, up a little. You with me for the first dot? It's over a lot, up a little. Small, medium, large. A half, root 2 over 2, root 3 over 2. Small, medium, large. It's over a large amount, up a small amount, huh? So it's over root 3 over 2, up a small amount, up a half. Good so far? Okay, what about the one in the middle? That's medium, medium. Root 2 over 2, root 2 over 2. That's not the answer, is it? Let's keep going. What about this dot right here? What's he? He's over a small amount, up a large amount, isn't he? He's over small, over a half, up a lot, up root 3 over 2. Is that good? Over small, up a large. Over small, up large. X is small, y is large. Over and up. Now, cosine is x, sine is y. Cosine, sine, cosine, sine, cosine, sine. Okay, so what? I'm looking for tangent. Well, what's tangent? Tangent, yeah, is sine over cosine. Okay, so if let's just go through it here. If I take this one over this one, I'm just going to guess. Root 3 over 2 over a half. Would that work? Remember what you do with the fraction in the bottom. Flip it up. 2 over 1, 2's cancel. What is it? Root 3. Not root 3 over 3. It's got to be this one. It's not the middle one. And I'll prove it is that other one. So everybody sees so far why it's not that top one. Am I going too quick? So I got the coordinates of all these points. I went over large, up small. Right? Everybody see how I get? This is the most important thing. Make sure, please, come see me. Be glad to spend some time with you and I can get you really comfortable, I think, with these dots. If you get these dots, small, medium, large thing, you can roll all this stuff out. We'll be using this all semester long. You want to get really comfortable with these dots. If you're not, please come see me or Roberto or something. Be glad to help you. Grab me after class even for just 5 minutes. Probably can get you started in the right direction. Make sure you're comfortable with these coordinates, small, medium, large. They are the foundation. Unit circle is the basis for everything we're going to do. So make sure you get the unit circle. So you see what I'm doing? I'm going over a large amount, up a small amount, right? So that's how I got over, up, medium, medium in the middle. The one here is over small amount, up large, over small, up large. Cosine is always x, sine is y, cosine, sine. Okay, so tangent, sine over cosine. I just tried it. I just said, well, how about this? Maybe it's the first dot. So I put sine over cosine. Fraction of the bottom flips up. 2's cancel. Root 3. No. That's not root 3 over 3. That's wrong. Okay, so it's got to be this one because it's not the medium stuff, right? There's no root 2's here, right? So it's not the medium one. So it's got to be this one. Let me prove it. Tangent. I'm over here. Change my color. So tangent is, again, sine over cosine, so it'd be sine over cosine. It's a little weird. Sine over, kind of making that big, aren't I? Sine. So it's a half over cosine over root 3 over 2. Is that right? It is. Grab this guy, flip him up. It's a half times 2 over root 3. Good so far, right? I just grabbed that fraction on the bottom and flipped it up. It's upside down. What happened? 2's cancel. You get 1 over root 3. Now, is that the same as this? Yeah. Remember you never leave roots in the bottom of a fraction? What do you always do with roots in the bottom of a fraction? Multiply top and bottom by that root. Do you remember that from your algebra days? Right? Whenever we have a root in the bottom of a fraction, we never leave it. We multiply top and bottom by that root. And so 1 times root 3 is root 3. And then root 3, plane 3. Yeah, right. That's it. This is my baby right there. So what is that angle? What is that? 30 degrees. Right? Remember, it's just 30, 45, 60, huh? So that's 30 degrees. Got to convert that. So let me come over here because they want radians. They always want radians. So we take our 30. You probably know by now it's pi over 6, huh? Just multiply. Put the 180 on the bottom, pi on the top. 30 goes into 180. 6 times it's pi over 6. Positive pi over 6. Good on that? Making sense? Questions I can answer? All right. All right, try that one. So it's saying tan inverse root 3. So draw yourself a little unit circle. Find out the quadrant you're in. Look at the 3 dots. Small, medium, large. I love to hear Mr. He's voice in the hall. That was Jin He, one of our instructors here. It was Mr. He that hired me. He's one of the 10 years ago when I was applying for this job. These jobs are very competitive. Probably, I don't know, 40, 50 people apply that all have masters in math. Anyway, long story short, they make you do a problem in front of the committee. There's like 5 or 6 math teachers there. One of the things in your interview is a surprise math question, and which you don't know what it is. But anyway, so they gave me some kind of logarithm question thing. Anyway, and I'm working on the logarithm on the board in front of the committee, and basically if you mess up the problem, you're done. If you make any mistake, because there's 40 people that all have master's degrees, and you mess up the problem, Anyway, so I remember solving the problem, and thinking to myself, so after I finished it, I think that's right. But it's easy to make a small mistake, So I'm just thinking, boy, I hope I got that right. I think I did. I'm kind of looking at it, thinking I don't see any mistakes, but maybe I missed. I'm thinking, and normally, committees are silent; they don't say anything, right? So Mr. He, the Chinese gentleman that was in the hall there. So I remember him right as soon as I finished. I stopped. And it was all quiet, and Mr. He goes in his Chinese accent, "Good job." I remember thinking, "Oh, good. I must have." The Chinese gentleman says, "Good job." I must have not messed up anyway. So I remember his voice was music to my ears. They, "Good job." All right. So tangent inverse of square root 3. How do we do that? So first quadrant, right? Positive. We're positive in the first quadrant there. So we're up here like that, right? It's going to be one of those 3. It's not the fourth quadrant because it's not negative. So, which of those 3? Well, again, we just did this, huh? So the coordinates are over a large amount, up a small. I'm not even going to do the middle. It's not the middle, huh? There's no root 2's here. It's not the middle. Over a half, up root 3 over 2, because it's over small, up large. Good with the over, up, and the cosine is x, and the sine is y. Cosine is x, sine is y, like that. Okay. So, it's going to be this one, because we just basically did it, huh? Yeah, I'll certainly will. So tangent is sine over cosine, right? That's got to know that fact. Sine over cosine. So sine root 3 over 2 over cosine over a half like that. And so then you grab that half and you flip it up. So root 3 over 2 times 2 over 1 cancels out, and sure enough, it's root 3. So that's our baby right here. What is that? That's 60 degrees, huh? Because remember, it's 30, 45, 60. So that's 60 degrees, which you probably know is pi over 3, but if you're not sure, go ahead and convert it. Put the 180 down here, the pi up there. 60 goes into 183 times pi over 3. Getting more comfortable? Seeming easier? These inverse trig functions? No questions? Other questions on that one? Okay, so hit sine inverse of negative 0.69. You got to make sure you're in radian mode. So make sure your calculator's in radian mode. What should it be? It's going to be something like 0.69. So I don't know. It's going to be like negative. Well, I don't know. So it's half a pi. So how about 1.5? So it's maybe 1.1 or something like that. Negative 1.1. What do you get?
0.761.
Okay, maybe. I'm just trying to guess. I'm probably just off. Anybody else getting something like that? Sounds right. Okay, good. Now they want me to round it to the hundredths place. 100 has 2 zeros, so 2 places. So we'll just say negative 0.76. Now you guys are in radian mode. That's the radian. That looks about right. So there we go. Is that okay? Just making sure you're in the right mode and all that.
I got an error.
An error on that?
Yeah.
Sine inverse. Did you do the negative instead of the subtraction, maybe? Just guessing. Come up after. I'd be glad to help you figure out what that is. But they get real picky about negatives versus subtractions. I don't know. But anyway, if you have trouble, come on up. If your calculator's not giving you that value, come on up. It takes 10 seconds, and we'll get you rolling. Okay. So cosine inverse. So put in root 3 over 9. Hit the cosine inverse. Make sure you're in radian mode. and you should get an answer rounded to 2 decimal places. What is it? 1 point. How about one more decimal? 1.3. 1.38. Anybody else getting that? 1.38. Yep. Looks like we have agreement. 1.38. So if you're having any trouble entering that, be glad to help you. Just take 10 seconds. Run up right after class real quick before you run out the door, and we'll get that straightened out. All right. Is that too quick? Y'all got that copy, Deb? So. Okay. Sine inverse of sine of pi over 5. Sine inverse of sine of pi over 5. So, any feelings? I want you to get in touch with your math feelings here. Any feelings when you first look at that?
Solve the parentheses first.
We could definitely do that. I just mean like final answer. Anybody? What's that?
Do you cancel out the signs?
Yeah, that's generally right. Now, there's a couple tricky cases where you can't, but in general, you're totally right. They're going to go boom, boom, and the answer is going to be pi over 5. That is the answer. Now, it won't always do that, and that's the trick. I want to show you when it will and when it won't, but it often, and I'll expand upon often in a minute, but for now, let me say, yeah, that's good thinking. If you're kind of looking at that and going, well, aren't those the opposites? Don't they just cancel? Mostly, yeah. And again, I'll explain mostly in a minute. But yeah, basically, yeah, that's the right thought. Those are opposites, right? It's sine inverse sine. They're opposites. If they undo each other, it's like me saying, what if I take bread and I put it in my toaster? You know, I don't know. And it's just going to be weird. Well, no, I guess it kind of works. So if I take bread, and I put it in my toaster. Okay, what'll come out of my toaster is toast, of course, and then I'll put it in my inverse toaster, which is weird, inverse toaster, and what'll come out after the inverse toaster? Well, it's back to bread. So in other words, it starts the way it ends, because you run it through the machine and the inverse machine. You tracking with me? And that's what we're doing. See this pi over 5? I want to make sure this is really clear what's happening. The pi over 5 is being plugged into that machine, right? That's how you want to think about functions. That'll help you. That's why I'm doing all the toaster talk, because I've noticed as I teach calculus and stuff that people get really confused. They don't realize it's for example, like later on you'll have like sine of x over x. You'll have functions like that. It's something we do a lot in calculus. Students that cancel the x's are missing it completely. But I know that's common. You think we can just cancel those x's? The ball game is going right past you if you're doing that. But I want to help with that. I don't mean to be sarcastic about that, but the truth is it is. Because you're not realizing that x is being plugged into a function. That x is plugged into a toaster. You can't, it's not, that x is not loose and free. It's not that, now if the x was in the front, if you had like x sine theta over x, yeah, you could totally cancel those x's, no problem. Because that x is loose and free, he's just in the front, he's just an x. But anything to the right of sine or cosine or tangent or f, if I said f of x over x, you can't cancel those x's, huh? Because this isn't multiply, is it? This x is plugged into the toaster, isn't he? He's in there. He's not loose and free. Right? So you want to think that way about things to the right of a function in sine, cosine, tangent, log, exponential. Those are all functions. Everything's functions, pretty much. So anyway, so this pi over 5 is really plugged into the sine function. He's not just times. The parentheses don't always mean times in math, do they? This means plug into the toaster here. Right? It's not just sine times pi over 5. It's sine of pi over 5. It's pi over 5 plugged into the sine machine. Right, okay, and then something pops out of that and then goes into the inverse sine machine. So if you take a piece of bread and you put it in the toaster, then you put it in the inverse toaster, what's coming out? Well, it makes it back the way it started. Because a function and the inverse function, the inverse function undoes whatever the function did. Right? So sine inverse undoes whatever sine did to the thing, and it comes back out the same way it started. That's right thinking in general. When I keep saying in general, usually, typically, when does it not? Here, let me go to a fresh page. Sine inverse of sine of any x is just x, that's supposed to say sine there, is just x whenever x is in the restricted zone. What do I mean the restricted zone? Well, for sine inverse, negative 90 to positive 90, right? As long as the x is in that zone, the restricted zone, you know, the zones I told you about, then yeah, totally going to work. Going to be exactly that. If the x gets outside of that zone because of this zone restriction stuff, if you said what's the sine inverse of the sine of, you know, something like 82 degrees, yeah, just 82. Because 82 is between in the zone, negative 90 to positive 90, no problem. But if you asked what's the sine inverse of the sine of 120, it's not going to be 120. Why not? Well, it couldn't be. Because the answers always have to be between negative 90 and positive 90, don't they? Well, how do you do it then? Well, you got to go over here to 120, which is past 90, and cast it back in the zone. It's going to be the same angle, but in the zone. That's what it'll do. So it won't just be 120. It'll be whatever does the same thing as 120 in the zone. What does the same thing as 120? Well, it's 30 degrees past. So it's actually here, 30 degrees past. It'd be negative 60. Why isn't it up here? It's not the first quadrant because sine is negative there. It's the fourth quadrant. Anyway, we'll get to it. I'll do more detail in a minute. It would not be 120. It would be negative 60. So that's the answer. As long as it's in the restricted zone, yeah, that's true. They just undo each other. Sine inverse and sine, cosine inverse and cosine, yeah, they're opposites. As long as it's in the zone. Let's say a couple more words about the zone. Sine inverse of sine of x, it equals x when x is in the negative 90 to positive 90 zone, as I just said. Okay. Now, careful. Watch this trick, which they're going to pull on you. What if I switch these guys? Well, right now, what is this x right here? Do you see this x as an angle? This x is an angle. But if I rewrite this and I put the sine, regular sine on the outside, and put the inverse on the inside, this x is not an angle. It's an answer. Why? Because it's being put into sine inverse. It's all about your position, right? Remember, what do I put into a toaster? Bread. What do I put into an inverse toaster? Toast. Turns it back into bread, right? Remember, switch inputs, outputs. So if something is being put into sine inverse, it's an answer, not an angle. So you always got to be aware of that. Well, so what? Well, what kind of answers come out of sine? That's an answer, not an angle. Right up here, this one's an angle because he's just being put into sine, regular sine. It's an angle. We know about angles. But what kind of answers? Like if I take the sine of 129 degrees or whatever, use your calculator. You know, what kind of answers do you get out of sine? What's the biggest answer you ever get out of sine? Biggest thing you're ever going to get out of sine? Yes. Remember the graph? Right? Answers are y values, right? Here, the angles, these are angles, right? This is, 0, this is 360, 2 pi, or, 2 pi, right? Those are angles on the x-axis. There's a lot to remember here. You got to keep together the graph, the functions, kind of keep it all together. I know I'm throwing a lot of information at you fast. Try to track with me. Think about the graph. We just did graphs, right? Last week. Think about the graph. And the x-axis is angles, isn't it, right? 2 pi, this is 2 pi, this is one full cycle, 2 pi, right? The x-axis is angles. The y-axis is answers. Well, what's the highest answer you ever get out of a normal sine? 1. What's the lowest? Negative 1. The answers that you get out of normal, if there's not an amplitude change or something in the front, normal sine or cosine, the highest and the lowest are 1 and negative 1, aren't they? So, this x will just equal x if x is between negative 1 and positive 1. Do you see that? Everybody see that? Because that's the zone for this x, because this x is an answer. Whereas this one up here is an angle. So if you're an angle, you got to be in the angle zone. If you're an answer, you got to be in the answer zone. How do you know what it is? What is it being put into? Is it being plugged into sine inverse? Then it's an answer. And it's got to be in the sine answer zone, which is -1 to +1. If it's an angle, meaning if it's being plugged into regular sine or cosine or tangent or whatever, then it's an angle. And for this to be true, for them just to cancel, for sine inverse and sine just to cancel, and it just equals x, you'd have that angle would have to be in the angle zone, -90 to +90. All right, did you catch all that? Is that making sense? Let me add one more mystery to it. So what if I asked you tangent inverse of x, would that just equal x? Sure, as long as x is in the zone. What's the zone for this x now? Think with me. Think on your own for a second. Answer in your own minds for a second. Is that x being plugged into tangent inverse? Is that an angle or an answer? What do you put into tan inverse or any inverse function? Do you put in angles? No. You put angles into regular functions. You put answers into inverse functions, right? That x is an answer. It's not an angle. Okay, so that means this is true if this answer, x is whatever it is in both cases, it's an answer. So is it in the answer zone for tangent? Well, what's the answer zone for tangent? The answer zone for sine, there's a sine, -1 to +1. What's the answer zone for tangent? Remember the graph of tangent? You just did him in the homework last night, right? What's he do? He snakes. You don't have to remember every detail, but remember he snakes like this. How high does he go? Forever up, forever down. So this is true as long as x is between -infinity and +infinity, which is anything, right? So yeah, that one's always true in that situation. Is this too much information too fast? Are you seeing all this? So when they give you the sine inverse of the sine, or the cosine inverse of the cosine, or the tangent inverse of the tangent, they put the same trig function together, but the regular and the inverse, and they're asking you, do they just cancel and it's just x? Most of the time, yes. How do we know when? As long as the x is in the zone. But the trick with the zone is you got to determine if that x is an answer or an angle. So if it's being plugged into the inverse function, it's an answer. And so then you got to know the answer for tan inverse goes -infinity to +infinity. But for sine and cosine, it's -1 to +1, isn't it? Remember the graphs. Okay. So with all that, I think we're ready to answer this next question. Tangent of tangent inverse of 8. Now, we'd like to say it's just 8. Can we? Can we say they just cancel, boom, they're opposites, they undo each other like a toaster and a detoaster or inverse toaster. They just cancel each other out, and it's just back to 8. Is that true? Well, yes, if 8's in the zone. What's the zone? What is 8 here? Is it an answer or is it an angle? Answer, because it's being put into an inverse trig function. So if it's an answer, what's the answer zones for tangent? As we just saw, -infinity to +. So all 8's, yes. Yes, it's just 8. Good with all that? All right. So, tan inverse of tan of 4π/3. All right, let me give you a second. So first question you want to answer, you'd like to say maybe it's just 4π/3. Maybe they just cancel and the answer is 4π/3. Maybe not. First decide if 4π/3 is an angle or an answer. Don't decide because it kind of looks angle-ish. Don't do that. They could fool you with that. Don't rely upon that. Look where it's at. What is it being plugged into? That's all that matters. Don't try to do some looks thing. Just say, what's it being put into? It's immediately being plugged into regular tangent. So what does that make it? An angle or an answer? It's an angle. So it is an angle. It is an angle. It looks angle-ish, and it is. It is an angle. That's an angle, right? Because it's being put into a regular trig function, right? If they did it the other way, if they did it like this, and they could, then that would be an answer. Same exact 4 pi over 3. Could be an answer or an angle. That would be an answer because now it's being put into tan inverse. You put answers in the inverse trig functions, like you put toast back into the detoaster, right? So that would be an answer. Anyway, that's not what they asked me. All right, so it's an angle. Okay, great. So what? Well, so is it in the angle zone? Is it in the angle zone? What's the angle zone? For tan inverse and sine inverse, it's negative 90 to positive 90 for tan inverse and sine inverse. Cosine inverse, it's 0 to 180, as we saw, right? So is it in the zone? 4 pi over 3. 4 pi over 3. If you're not sure, take the 4 pi over 3 and convert it. I think better in degrees than radians myself. Maybe you do too. Just convert it. Pop in a 180 for that pi, right? If you already know, then great. You don't need to do this. But if you're not 100% sure, then convert it to degrees. 4 pi, remember pi is 180. Just pop a 180 in the place of pi, right? 3 goes into 180 60 times. 4 times 60, 240 degrees. Not in the zone. It's way out of the zone. 240. 240. That's somewhere over here, isn't it? It's almost to 270. 240. So no, the answer is not going to be 4 pi over 3. Right? It's not in the zone. Well, then what's the answer? That same position over in one of the zones will be the answer. So we have to move that to one. Well, how do you know which zone? It's all about whether it's positive or negative there, right? Remember, first quadrant, everything's positive. The other inverse quadrant is for the negatives. So is tangent going to be positive or negative in that third quadrant? All students take calculus. Tangent is positive. Okay? So then cast it back into one of the zones. Which quadrant is tangent also positive? Well, first, huh? So cast that same angle into the first quadrant. What do I mean same angle? Same reference angle. Remember we talked about reference angle? What is a reference angle? What does that mean? Reference angle. You refer it, but refer it with what? To the x-axis. Remember, it's all about the x-axis. That's what we mean when we say a reference angle. We mean look at the thing, look where you're at. How far are you from the x-axis? Don't worry about the y. Why the x? Because we started 0 degrees on the x. All these angles start from the x. That's why it's always with reference to the x-axis. So how far is this? 240 is how far off the x-axis. It's almost to 270. It's 30 degrees this way, but we don't care about that. It's 60 off of the x-axis, isn't it? Because this is 180, and 240 is, right? 240 is 60 more. So it's 60 off the x-axis. You with me? So that means you bring it back over here, and you say it's the same as 60 degrees in the first quadrant. So the answer to this question is going to be 60 degrees. Got to change it to radians, but 60 degrees, not the 240 or the 4 pi over 3. So the answer is going to be 60 degrees. Convert that to radians. So that is what? 180 on the bottom, pi on the top. 60 goes into 180 3 times. Pi over 3. So there, the answer came out pi over 3. The answer was not 4 pi over 3. Everybody good with that? You see why we had to do a little more work? It was not in the zone. If it's in the zone, they just cancel. If it's not in the zone, you got to do the work. Is that okay? Questions I can answer? Everybody see that? Right? 240 was 60 off the x-axis. So I did 60 off the x-axis in the first quadrant. The other place where tangent is positive. So the answer is 60 degrees. Had to convert it. All right, I'll keep the super tricky one. Let's see how you're doing with all this material. These can be tricky. Sine of sine inverse. Whoops, there's no more parentheses there. Okay, let me give you a minute. Try it. Feel free to talk about it. There's a lot to learn here. Try that one. First thing to determine is if that 2 pi over 3 is an answer or an angle. Again, don't try to do it by a looks thing. Think about where it's at. what's it being plugged into? And so what does that mean about whether it's an answer or an angle? So all of this is on the non-calculator part of the test. You need to be able to do this without a calculator on this one. So what do you think? 2 pi over 3, answer or angle? Good, it's an answer. Sure looks like an angle, doesn't it? It's not an angle. It's an answer because it's being put into sine inverse, right? We put answers into inverse trig functions. Angles into regular trig functions. So that's an answer. Answer, okay, okay. So is it in the zone? What's the answer zone for sine? Right? Remember sine? Positive 1, negative 1. The answers are the y-axis. So it's negative 1 to positive 1. So is it in that zone? Is 2 pi over 3. What is... We need like a regular number here. 2 pi over 3. Is that like between negative 1 and positive 1? Again, you don't need to have, I mean, you can use calculator, but can you do this? You need to be able to do this on the test next week without a calculator. And you think, well, I can't do all those numbers. Not exactly. You don't need to do the exact. Just think with me for a second. What is pi? 3.14, as far as a number goes, right? It's 3.14, blah, 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 right? You think, well, I got to do all those. No, just think with me for a second. Just think, guys. What is 3.414 over 3? I don't know, but it's bigger than 1. Right? Just forget about the 2 for a minute. Just 3.14, like more than 3, over 3. What's bigger than 1? Right? If you put a bigger number on the top and a smaller on the bottom, 3 goes into 3.14 more than 1 time. Just a little bit more than 1 time. Right? You know that's more than 1. Times 2, 2 times something that's more than 1, 2 times a number more than 1. You're getting something more than 2. For sure. I don't need to do all the calculation. I just need to think it out logically. It's got to be more than 2, right? I'm multiplying 2 by something that's bigger than 1. Have I lost you? Right? Everybody see that? Right? 3 has to go into 3.14 more than 1 time, doesn't it? Take a bigger number divided by a smaller number, you get more than 1. 1 point something. Times 2 is going to be 2 point something, isn't it? So it's not between negative 1 and positive 1. It's 2 point something. I don't care what. It's not between negative 1 and positive 1. Okay, so it's not in the zone. Right? We clear on that? I know without a calculator, it's not in the zone. It's not between negative 1 and positive 1. It's 2 point something. So what does that mean then? That means you're sticking in it. Now careful. When we did this last one, we looked and said, okay, 4 pi over 3 was not in the zone. Where is it? 240 degrees. And then we found that was 60 past the x-axis, and we cast it back in the first quadrant. That's because that was an angle, right? With the angles, we cast them back. But if you're talking about an answer that's out of the zone, you can't cast answers anywhere. There's no way sine can ever come out to something. This one is undefined. Oh, yeah, it's already checked down there for you, huh? I didn't realize that. You guys are like, oh, we know the answer, Mr. Aaron. It's undefined. No way. No way. You cannot have an answer that's out of the zone. You can have an angle. Now, I know that could probably be confusing. Look back. Think, well, we did this one. Yeah, because that was an angle out of the zone. So for the angles out of the zone, yeah, we can cast them back because the unit circle just keeps going round and round and round. You can cast it back anywhere. But for answers, you can't have an answer out of the zone. Try your calculator, it'll just say air. If you type this one into your calculator, it'll just say air. There is no way you can have sine inverse a 2 pi over 3. That's impossible. Because what? What's that saying? That's saying the sine of what angle is 2 pi over 3? There's no angle that can come out with a sine value that's over 2. Sine can only go up to 1 and down to negative 1. That's all sine can do. He can't go up to 2. You're basically asking, saying, hey, sine, where do you go up to 2? And he's saying, I don't go up to 2. There's no angle that does that. That's what's happening there. Does that make sense? So this is going to take some time. It really does. These aren't simple concepts, right? I didn't just say Abraham Lincoln was the 16th president. That's it, right? And again, I'm not. I love history. I'm not putting. I love it, but I'm saying there's something a little more straight about history, and math and science is like Chinese a little bit, right? So you got to spend time with this, working these problems, thinking about these concepts. To math, a lot of the battle in math classes is keeping recognition of when the game has changed. Why am I saying they're changing the game here? Why is this question fundamentally different than the last few questions we've answered?
There's different,
Yeah,
functions.
different trig function. It's not just sine of sine inverse, cosine inverse, tangent inverse. They're mixing them now. They're mixing the trig functions. Do everybody see that? Right? Look back here. See, this was sine inverse. This was tangent inverse, or tangent inverse tangent. This was tangent inverse. This was sine inverse sine, right? So they were all the same trig function, just the inverse and the regular up to now. Now it's a total mix. So there's just no way the answer is 4/5. We're not even gonna think about that, right? There's no way. They don't cancel. No way they cancel. They're not just the opposites. So what do? Well, we do something kind of difficult. I'm sure you knew I was going to say that, huh? All right, you ready? Here we go. So this is really important. Let me just tell you right in advance. This is super important. There's 2 of these on the next exam. It's really, especially it's valuable because it's in calculus. You do exactly this in calculus, especially Calc 2, where you got to do some special kind of things. So you really need to master this. So track with me. This is super important, although it's a bit difficult as well. So right in here, let's just take this little piece out. So it says cosine inverse of 4/5. Now, again, 4/5. Is 4/5 an angle or an answer? Look at where it's sitting. It's being put into an inverse trig function. So it is an answer. So this is going to equal some angle. Let me just call it theta. Right? Because if you put it, this inverse trig function, which means you put it in an answer, get at an angle, it's going to equal some angle theta. You with me? So far, do you understand the basic meaning? I'll come back to the tangent thing in a minute. But basically, I'm saying all of the cosine inverse of 4/5, I'm calling it theta. I'm just like naming a pet. You're Rover. You're my dog. You're Rover now. I just gave it a name. That's all I did. I just said, hey, all of you, you're called theta now. I just gave it a name. I just named it. That's all I did. Because it does equal some angle. Why? How do you know? Because 4/5 is an answer, so it equals an angle, right? So all of this cosine inverse 4/5 thing is some angle. Call it theta, whatever it is. Call it theta. Okay, so what does that mean? Well, that means if the cosine inverse of 4/5 equals theta, it's being called by the name theta, then that means the cosine of theta is 4/5. I just switched them. That's okay to do, right? Remember, it's regular cosine. Everybody knows cosine inverse, regular cosine, right? Regular cosine, you put in angles, get out answers. So I just switched these guys because I wanted to get back to regular trig. You with me so far? So the cosine of whatever this angle is, I don't know, I'm looking for it, is 4/5, right? If the cosine inverse of 4/5 is theta, then the cosine of theta is 4/5. Okay, so what? Well, now I'm going to take that little fact and I'm going to put it on the unit circle. It's always about the unit circle, isn't it? Okay, which quadrant am I in? It's one of these two, right? No, it's not one of those two. It's the cosine inverse is always the top two, isn't it? So it's one of these two. Cosine inverse does those two, right? Zero. And which one? Is this positive or negative? Positive. So I'm in the first quadrant, right? So I'm in the first quadrant here, where everything's positive. Okay, now 4/5, I don't know that is. Just pick some pointer. I have no idea. It's not. I'm not saying it's 60 or I don't know. It's not one of my memorized values. It's not 30. It's not 45. It's not 60. I don't know where it is. I'll just put a dot down for just have something to look at. So, and I'm going to make a triangle to that dot. This is my angle theta here. I'm going to make a triangle that reflects this truth. How are we doing? There's a few steps to this process. This will not come to the casual. It will come to those who spend time working on it. You can do it though. Hang with me. You can get this down, and I'm glad to help. Cosine, now I got to make this triangle reflect this truth. The cosine, what is cosine? Remember SOHCAHTOA? SOHCAHTOA, what is cosine? Adjacent over hypotenuse. Bless you. Adjacent hypotenuse, right? This is the opposite side here. From the angle theta. From angle theta, adjacent side, opposite hypotenuse side. So cosine of theta is 4/5, which means adjacent over hypotenuse. So the adjacent is 4. The hypotenuse is 5. You with me? I just made that triangle reflect that truth. Is that good? The cosine of theta is 4/5. Now, can I find this other side with the Pythagorean, right? A squared plus b squared is c squared. There's a lot of steps here. A squared plus b squared is c squared. So that means 4 squared plus b squared is 5. You probably haven't memorized it's 3, 4, 5, huh? The 3, 4, 5 comes up a lot. It's going to be 3, but I'll go through the formalities because sometimes they're not clean. 16 plus b squared is 25. Subtract 16. B squared is 9. Rooted. B is 3. Plus or minus, but we know it's plus. We're in the first quadrant. So plus 3. Good to there? Let me slow down a bit. Everybody see what I'm doing? It'll be the same every time. So after you've done this a couple times, you'll have the rhythm. It's pretty much the same. We make these little triangles, do the Pythagorean, put the angle. It's pretty much the same every time. When? When we have a mix of functions and one's an inverse and one's a regular. Everybody recognizing when? That's a lot of the battle in a math test is recognition. When do you do this whole triangle theta thing? When you've got a mix of trig functions, one's an inverse, one's a regular. So that's when you do this whole thing. You call this whole thing theta, and you say, well, cosine of theta is 4/5. Then you make that in the triangle. Cosine of theta, adjacent hypotenuse, 4/5. Do the Pythagorean, 3, 4, 5. Okay, so what? So now, the whole question becomes, bring it up here. Look at this now. What does this say? Tangent of what? All of this is, what did I call all of this? Theta. Our question is really, what's the tangent of theta? Right? Because the whole cosine inverse, 4/5, I said, you're called by the name theta. You're over. Right? I named it theta. And that meant cosine, that meant all this triangle stuff. So tangent of cosine inverse is tangent of theta. So they're really asking, what's the tangent of theta? Right? I called all that cosine inverse stuff theta. Okay, so the whole question is boiled down now. What's the tangent of that theta thing I made up? What is the tangent of theta? We'll look at the triangle. What's tangent? Opposite over adjacent. Right? 3/4, done. Opposite over adjacent. We're done. So we made a triangle that reflected the cosine inverse truth, did the Pythagorean so we had all 3 sides, and then said, okay, so it's really just tangent of that angle, which is opposite over adjacent. That's how we'll do all of these. 3/4. Good on that one? Questions? Kind of thing you need to see a couple times, I think, because it's pretty much the same every time. Okay, so let's try that one. So sine of cosine inverse of root 2 over 2. Okay, so try that one. So what do I mean? So call all of this theta. Cosine inverse is theta, right? Which means cosine of theta is root 2 over 2. Remember, root 2 over 2 is an answer, isn't it? It's being put into an inverse trig function. So root 2 over 2 is an answer. So you put in an answer, get out an angle, call it theta. So now draw a little triangle. We're first quadrant again, right? We're first quadrant. Draw a little triangle where the cosine of theta is root 2 over 2. You know, that actually is one of our memorized values, isn't it? You might be able just to look at that and go, oh, I just know that one. The last one was not one of our memorized values. So really, you could just look at that one and go, I know where that's at. I don't need to make up triangles. I know right where that's at. You could do that on this one. But there's other ones you can't. So either way, on this one. So make up a triangle. You always put theta right next to the x-axis, reference angle. Cosine of theta. Now what's cosine? SOHCAHTOA. Cosine's adjacent over hypotenuse. So root 2. What am I doing there? So it's root 2 over 2. Huh? Adjacent over hypotenuse. Is that good? Then you could do the little Pythagorean thing. Right, a squared plus b squared is c squared. So root 2 squared plus b squared is plane 2 squared. What's root 2 squared? Plane 2 plus b squared is 4. Subtract 2. B squared is 2. B is root 2. So this is root 2. Good? And so the final question becomes, sine of what's all this called? Theta. So what's the sine of theta? Sine is opposite over hypotenuse. Am I going too fast? Sine is opposite over hypotenuse. This is adjacent here. Sine is opposite over hypotenuse. It's root 2 over 2. It's the same thing we started with. Of course, because we know where that's at. That's 45 degrees, isn't it? That's the medium value. So this one was kind of weird. You really could have just looked at it and go, that's 45 degrees. I know the sine of 45 degrees, root 2 over 2. So you didn't really need to do the whole triangle thing on this one because it happened to be one of our memorized spots, but that's not typical. Now let's go on to one that does. So tangent of cosine inverse of minus 1/11. Man. Let's try that one. You know, let me help. If you what's a good way to do that? If you'd rather not worry about all the negative, you got so much to worry about. If you'd rather not worry about the negative stuff, you could, I mean, you got to worry about it a little bit, but what quadrant are we in? Negative 1/11. Where's the negative zone for cosine? Cosine goes from here to here. We're in the second quadrant, aren't we? You with me? Remember, cosine inverse, it's first or second quadrant. Tangent inverse is first or fourth, and sine inverse and tangent inverse are first and fourth. So it's over here. So and in the end, the question is going to be tangent of that angle. Tangent. What is tangent? Remember, all students take calculus. So in the end, the final question is tangent. What is tangent in the second quadrant? Positive or negative? Negative. So you know the answer is going to be negative. So now just forget about everything. Just do you could just do 1 and 11 and forget about the negative. You know in the end, the answer is going to be negative. Because you know you're in the second quadrant, tangent's negative second. Anyway, just take it from there. Just do the regular thing. Right? You call all this part theta. All of this. Call it rover. Call it theta. You guys doing okay? So technically this triangle's in the second quadrant, but if you want to just stick it in the first quadrant and in the end make the answer negative, that's fine. It'll work out fine. If you don't want to mess around, that's fine. I'll go ahead and do it technically correct where it is, the second quadrant. Remember, theta is always the angle to the x-axis, isn't it? It's a reference angle. Never put theta here, for example, right? That would be to the y-axis. We always make theta the reference angle to the x-axis. That way it's the same as the first quadrant because 0 degrees is the x-axis. Okay, so cosine of theta, so katoa. Cosine's adjacent, so this is adjacent, opposite hypotenuse, right? Cosine's adjacent over hypotenuse. So this is minus 1 over 11. That's where we get the negative. Again, if you want to skip the negatives and just make it negative at the end, that's fine. It'll be the same. It's technically back 1, up something, I don't know. That's why it's negative. But again, you can skip all that if you want and just make it negative at the end. Cosine's adjacent over hypotenuse. I got to find the other side, Pythagorean. So I bring that in. A squared plus b squared is c squared. So negative 1 squared plus b squared is 11 squared. 1 plus b squared is 121. Subtract 1. B squared is 120. Root it. So b is, that simplifies. What's that, 4 times 30? So that's 2 root 30. Right? 2 root 30. So 2 root 30. B is 2 root 30. So this side over here is 2 root 30, if you can read that. 2 root 30. Am I going too quick? Am I losing you? This is the opposite side. Is that okay there? Questions I can answer? So we're almost done. Does everybody see what I did? You just call the whole thing inside theta, which means cosine inverse of negative 1/11 is theta, so cosine theta is negative 1/11. You put that on the triangle, put theta to the x-axis. You could do it in the first quadrant, it's okay. Back 1, up, I don't know, hypotenuse 11, cosine is adjacent over hypotenuse. Do the Pythagorean. B is root of 4 times 30, right? 120 is 4 times 30. Root of 4 is 2, root 30. So put that in for B. And now, this whole question has become tangent of theta, hasn't it? Because I called the whole inside thing theta. So what's the tangent of theta? Tangent is opposite over hypotenuse. Opposite over adjacent. Opposite over adjacent. 2 root 30 over negative 1, huh? Opposite over adjacent. So that's just negative 2 root 30. Is that good? See how it came negative in the end? And again, you can just do all the work in the first quadrant and just go, look, I know it's really in the second quadrant, and tangent is negative in the second quadrant, so it's going to be negative. Or you could make the triangle really where it's at with the back and the up, and your signs will bear out that truth naturally. Either way. Is that good on that? I know that's not easy. About half the time, probably more than half the time, I sat in math classes, I didn't get it. I'd kind of go, I don't know what that teacher's doing up there, but I'm going to get all the notes down and look this over later. And you guys got YouTube. I didn't have YouTube. You could watch the lecture over again. So that's what it took for me. So if you're feeling confused, please don't think to yourself, well, I just don't get this stuff. I didn't either. Probably about 60% of the time. In lecture, it was just too fast for me. I would just go, I don't know what that teacher, he'd lose me about the first 10 minutes, and then after that, I would be lost. Anyway, but you can get it. But I'd spend hours and hours and hours later reading over those notes, reading them over, looking at the homework, checking the answers in the back of the book, seeing what I'm doing right and wrong, making a list of questions for my teacher to ask him in the halls. That's what it takes to master math and science. So you can do this stuff. If this is a little blurry right now, look this over again later. Check out the YouTube again later. Super important. 2 of these on the exam next week. Questions I can answer right now?
When you plug that in, that's the answer.
What's that?
When you plug it in.
Uh-oh, am I wrong? Is there something? So number 19. Secant of sine inverse. Yeah, see, you know, your question is a really good one. Let me say better what the answer is, because you said, well, if it's in the zone. Look what they're saying right here. They're saying, assume that x is positive and that the given inverse trig function is defined for the expression x. So they're saying, assume it's in the zone. That's what they're basically saying. Because you're right, you'd have to do that, we'd have to assume it's in the zone. Okay, so let's try this one. So we start here, and we call the inside theta. Give it a name, rover. Call it theta, right? So that means the sine inverse of x over the square root of x squared plus 4 equals theta. Good to there. So then that means the sine of theta is x over the square root of x squared plus 4. Get a little scribbly there. So far, so good. All right. Now let's just make a triangle. We'll just put it in the first quadrant because we don't know what x is, so let's go to the first quadrant. Make a triangle that reflects that truth. So this is theta. SOHCAHTOA, put it up here. Sine is opposite over hypotenuse. So we have opposite, hypotenuse, and adjacent. So the sine is opposite over hypotenuse. So the opposite is x. The hypotenuse is the square root of x squared plus 4. Good there so far? Right? The sine is opposite over hypotenuse. X over root of x plus 4. By the way, I noticed on this one, let me go back for just a second. Oh, no, not that one. One of the other homework problems, that they had the sine inverse of like 5x, and it wasn't a fraction. It's 5 there. You just put it over 1, huh? So that'll be opposite and hypotenuse. If they don't give you a fraction, which they don't on number, I think it was 17, I skipped it, just make the bottom a 1, right? Because 5x is 5x over 1. So your hypotenuse would just be 1. Your opposite would be 5x. Your hypotenuse would be 1. Good on that? If they don't give you a fraction, just put it over 1 to do the opposite over hypotenuse thing. Okay, anyway, here we've got a fraction. So opposite over hypotenuse. Now, how are we going to find this side? Well, Pythagorean, right? A squared, b squared, c squared. So we're going to go a squared plus b squared is c squared. So we don't know a or b or whatever. It doesn't matter. A and b are interchangeable. Plus x squared is c squared. So it's the root of x squared plus 4 squared, which is just going to tear off the root, isn't it? Let me slow down there for a minute. So everybody see what's happening? Right? A squared plus b squared is c squared. And the root squared, these guys just cancel each other, don't they? Rooting and squaring cancel. So you get a squared plus x squared is just x squared plus 4 plain, no more root. The square tore off the root. Good to there. So notice we have x squared on both sides. So bye-bye x squared. So we get a squared is 4. A is 2 plus or minus, but we don't care about all that because we're just in the first quadrant here. A is 2. Good. That wasn't too bad, right? Now we can answer the question. Which is what? See, the original question is secant. See here, secant of theta. So that's the real question. What's the secant of theta? Well, secant is 1 over cosine, isn't it? So the original question is secant of, and I called all that stuff theta. And so secant is 1 over cosine. So it's 1 over cosine of theta. What's the cosine? Adjacent over hypotenuse. Adjacent over hypotenuse. But then I'm supposed to flip it. Okay, if I just flip it right now? It's going to be hypotenuse over adjacent. Done. It's hypotenuse over adjacent. It's upside down of cosine, huh? We're done. That's the answer. Hypotenuse over adjacent.
Can you plug it in?
Sure. Square root of x squared plus 4. That. Questions I can answer on that one? Hey, by the way, why can't I go like 2 into 4? Or square root of 4 is 2 and then cancel the 2's? Pluses and minuses. I don't know if you know. Plus and minuses glue things together, which means you can't touch them unless you buy the whole pack. You just got to leave it. Plus and minuses glue things. You can't cancel these guys in any way on that.